Hi, I'm Pankaj Berde from Open Networking Lab. Today I'm going to introduce Open Network Operating System or Onos. Onos is the distributed network operating system for logically centralized control planes. What do you mean by that? Onos is the platform to build logically centralized control plane, providing global network view to centralized control applications. Onos addresses three critical requirements for SDN. It provides a platform for scale out control plane, provides highly available fault tolerant platform for control plane, and at last but most importantly provides a northbound abstraction for control applications. To do this, Onos is built with distribution at its core. Different parts of the data plane are controlled by multiple instances of Onos. These instances use OpenFlow for southbound interface. They need to coordinate with each other and they use distributed registry to cooperate with each other. They together work in tandem and create a global network view called network graph, which is a northbound abstraction for control plane applications. The control plane application use this abstraction to control the network. In a nutshell, this is a simple scale-out architecture that is highly available and provides a novel northbound abstraction network graph for applications. Let me show you a small demonstration of Onos. There is a user interface here and let me explain the GUI. There are three sections on this GUI. Top is the control plane, bottom is the flow monitor. The center of the screen shows the data plane of the network, typical of a service provider network. Each red circle is a core switch. If I click on the Onos instance 1, I can see only the red instances. So, that shows that these switches are being controlled by Onos instance 1. When I click on Onos instance 2, you will see only the yellow circles and these yellow circles are aggregation edge switches. Onos 2 controls these switches. These are hosts attached to each edge switch, but they are not shown in the GUI. The grayed out circles are actually inactive switches. Color circles are the active switches. Currently there are 106 switches in the network. So, you are seeing 106 colored circles. At the top in the control plane you are seeing the Onos instances. Each box is an instance of Onos running on a Linux server and each instance runs the OpenFlow controller, network graph stored in the Cassandra and distributed registry in Zookeeper. It is active when it is lit and inactive when it is grayed out. These are some action buttons which we will use later in the demo. In the bottom is the flow monitor. The network has 144 pre-provisioned flows. Flows take different paths through the backbone. Number of on the backbone link is the flows which are going over it. We will select a randomly one flow right now through the flow chooser. The flow monitor shows the source and the destination attachment points of the host. We are using iPerf to monitor the traffic. We use UDP at a constant bit rate of 1 Mbps. On the right side, we display the throughput as a sliding histogram. We will unselect this flow now. Now, we would like to demonstrate the scale out of the system. So, imagine you wish to expand your network. You would want to add more switches to your data plane and now that you scaled your data plane, you also want to scale your control plane. So, you want to add more Onos instances to your control plane. Let us add more Onos instances here. By pressing the scale out button, we are going to turn up 4 networks and turn up 4 Onos instances. While the scale up is happening, let me explain what is happening behind. The switches are being turned up and they are connecting to the controllers. The switch manager adds them to the network graph. The link discovery discovers the links and adds them to the network graph. Hosts are discovered and added into the network graph. While this was, now you can see all the colors lit up and then the switches are being lit up right now. We also went ahead and provisioned some flows and the flow manager is programming the switches. Let us add some more flows to see how this is happening. But yeah, now you can see the links and everything, the whole network discovered and everything lit up. This is the time we can to show that the new switches are active and being controlled. We will create a couple of traffic flows between them. We are creating a flow from LA to New York City. And when this flow is being created, you can see those flows onto the flow monitors. Now you can see the path has been computed and the shortest path has been found, and the traffic has started flowing for the flow. We can see similarly the other flow which we added, we can also see its path and the traffic which is flowing. Let us see how the new instances react to link events. Let us bring down the link, Los Angeles. Let's bring down the Los Angeles to Chicago link, and you can see there are 40 flows on that link. So once the link has been brought down, Onos instance 1 detected that the link has gone down, and that was propagated on each instances. Since the network graph is global, all instances see it and they compute new paths for the affected flows. The new flow entries are recomputed for the switches. Flow manager reprogrammed the switches and traffic started flowing again. Now we can see the flow counts on Los Angeles to Atlanta link has been gone up. And we can see on the monitor that the traffic is flowing and there was a slight dip, and that was the time when the rerouting happened. Now that the link is broken and the flows on the link have been rewritten to the next part, now you saw that the Onos scaling out by adding instances and reacting to flow and link events. Let us now do a fault tolerance demo. We want to show what we did for fault tolerance. With a single instance controller, a controller failure will bring down the whole network. As Onos is distributed, when an instance fails, other instances should be able to take over the control of the switches. Let us provision the switches with backup controllers. We will press the backup button now. Now we are going to bring down few Onos instances. So the GUI is sending the command to kill Onos JVM, and we are picking 3 instances. All network state is distributed across Onos instances with a replication factor of 3. So even if an instance goes down, other instances have the state and can use it. The distributed registry built on Zookeeper will elect a master controller for each switch. When switches connect to multiple Onos instances, but only one instance is the master controller. Others are waiting to take over in case master fails. Let us see how the system behaves with flow audition. So now what you have seen is the switches have taken the control over, and the other controller instance have taken the control over the switches. To see that the switches are still active and still in control, we are going to create a new flow. While the new flow is being created, if you note down onto the previous flow which we are monitoring, the flow had no dip in that, which means the traffic was continuously flowing and there was no drop in the traffic when the switches were being failed over onto a different instance. Now the new switches, new flows which we created have started the traffic, and you can start see the traffic flowing on it. And you can notice that the new instances are actually, the new masters are actually programming the new flows. Now let us see how the system behaves after a failover. Let us add the Los Angeles Chicago link back. So what will happen is when we create this link, the flows will get rerouted because there was a shorter part in some cases. So you can see the flow count on this link growing up, and you can see some flows have been finding the optimal path because of the new link. So, this shows that the control of the whole network was still functional after failover. So, let me summarize what we demonstrated. We demonstrated a global network view, we demonstrated scale out, we demonstrated fault tolerance, and we showed how Onos handles network events like adding flows and link failures. So, now that you have seen the demo, let me recap Onos architecture. Onos is distributed at the core. Multiple instances of Onos control different parts of the network. These instances coordinate among themselves using distributed registry. Working in tandem, these instances create a global network view which as the network graph, which is realized using distributed data stores. Control applications read the network graph for the centralized view of the network and annotate this graph to program the network. Program instances read these annotations and program the physical network in parallel using OpenFlow drivers. And we have got a great team behind Onos. Thanks for listening, and please visit our website at onlab.us.